Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is important questions of momentum. This question is from March 21, paper 42, question 1. Two particles P and Q of masses 0.2 kg and 0.3 kg respectively are free to move in a horizontal line on a smooth horizontal plane. P is projected towards Q with a speed 0.5, whereas Q is projected towards P with a speed 1 meter per second. So the velocity of Q is -1 and velocity of P is 0.5. Q comes to rest in the resulting collision. So after the collision, the speed of Q is 0 and the speed of P is V, and we need speed of P after the collision. So by using law of conservation of momentum, we can find the speed of P. So this is P and the speed of P is 0.5 and its mass is 0.2, and the velocity of Q is -1 and its mass is 0.3. So according to law of conservation of momentum, we have total initial momentum is equal to total final momentum. So momentum of P, m times v, so 0.2 times 0.5, and momentum of Q is 0.3 times -1. Momentum of P after the collision would be 0.2 times V, and momentum of Q will be 0. Hence V is 1 meter per second. The answer is -1. -1 means P is moving in this direction. But the question says find the speed of P. Hence the speed of P would be 1 meter per second, because in speed, direction is not important. Next question is from November 20, paper 42, question 1. Two particles P and Q of masses 0.2 and 0.5 kg respectively are at rest on a smooth horizontal plane. P is projected towards Q with a speed 2 meter per second. Write down the momentum of P. So momentum of P would be mass times velocity. M into V, so 0.2 times 2, which makes 0.4 kg meter per second. Part B. After the collision, P continues to move in the same direction with the speed 0.3 meter per second. So this is P and this is Q before the collision. And after the collision, P will move with speed 0.3 in the same direction. Find the speed of Q. Speed of Q would be V. This is Q and its initial speed is 0, or before the collision the speed of Q is 0. And the speed of P before the collision is 0.2. And the mass of P is 0.2 kg, whereas mass of Q is 0.5 kg. So total initial momentum before the collision is equal to total final momentum after the collision. This is law of conservation of momentum. So 0.2 times zero point 0.2, the speed of P was 2. Let me correct this. So 0.2 times 2 plus 0. Now after the collision, momentum of P is 0.3 into its mass, which is 0.2, and momentum of Q will be 0.5 into V. Hence V is 0.68. That's the final answer. Now the next topic in momentum is the loss in kinetic energy. Well, loss in kinetic energy is kinetic energy initial minus kinetic energy final. Initial means before the collision and final means after the collision. This question is from November 20, paper 41, and the question number is 1. A particle B of mass 5 kg is at rest on a smooth horizontal table. So this is B. And this is particle A. A particle A of mass 2.5 kg moves on the table with a speed of 6 meters per second and collides directly with B. So this is A, and the mass of A is 2.5 kg and its speed is 6 meters per second. And this is B. And B is at rest. And its mass is 5 kg. And this is the situation after the collision. A, B. In the collision, the two particles coalesce. Find the speed of the combined particle. So we need the speed of this combined particle. And the combined mass of both would be 7.5 kg. So according to law of conservation of momentum, we can easily solve this problem. So momentum of A before the collision and momentum of B is equal to momentum of this combined particle, 7.5 V. Hence V is 2 meters per second. This is the velocity and this is the speed. And the answer is 2 meters per second. The next part of this question, find the loss of kinetic energy of the system due to the collision. So this is very simple. So the loss in KE would be kinetic energy before the collision or initial kinetic energy minus kinetic energy final. This means before the collision and this means after the collision. So before the collision, particle A was moving. So we just need to write kinetic energy of particle A here. And particle B was at rest. So half, and the mass of A was 2.5 and its speed was 6. Kinetic energy final means kinetic energy of the combined particle. The combined particle. So half 7.5 and speed of the combined particle was 2. Half mv square, half mv square. Hence the final answer is 30 joules. This is the loss in kinetic energy. Well, I will discuss this question in my next lecture, inshallah. Allah Hafiz.